Today we are going to see another type of machine learning, that is the classification. So in the classification, what is the classification, how does it works, and we are going to see, we can also call it logical regression, logistic regression. Okay, and we are also going to see what is the label encoding and what is the one-hot encoding. Hello everyone, this is Sharda from GoEdu Hub. Can you please confirm me, am I audible, clear and loud? Okay, now I got confirmation, and now we can go ahead and we are going to see another type of machine learning, that is the logistic regression. Now you know the linear regression. Okay, in the linear regression we have relationship between the independent variable and dependent variable, and we are going to predict a continuous value. Like whatever we have in the features, we are going to predict some numerical value. And that numerical value can be anything. Like in the house price prediction, you can think about it, and whatever the output, what we are predicting a numerical value. Now if I talk about the logistic regression, or you can say classification, in this we are going to predict a class. Like what happens here, you can see this. Like we can compare linear regression and logistic regression. Okay, so in the linear regression, our output value is basically a continuous value. Okay, and another type is logistic regression. In the logistic regression, output is a class. This class can be either 0 or 1. This class can be either true and false. Okay, and this class can be multi-classes, like different type of, if we take example of fruits, then there would be 3 category of fruits, 4 category of fruits. So it is, you can say, categorical. It's not continuous. We are going to predict a value among those categories. Like in the output, we have certain categories. Okay, so basically we have certain categories here, like 1, 2, 3. So in the output we have some categories like 1, 2, 3. Some values are belonging to category 1, and some values are belonging to the category 2, and some values are belonging to the category 3. Okay, again I can define classification. It is a type of supervised machine learning, and in which we train a model with certain data, given data, and make the new observation in the form of some category. You can say it is a process of categorizing a given set of data into certain classes. Like you can take example of mails. Email, we can categorize email into 2 categories, either spam or not spam. Okay, so here 2 classes. One class is the spam and another class is not spam. So the process starts with the predicting the class of the given data point. The classes are often referred to as a target, or you can say sometimes we call it label, or sometimes we call it category. Or sometimes we call it class. So classification is a predictive modeling task, and in which we are approximating our function from input variable to some discrete output. Here our output would be some discrete value. Our main motto is to identify which class and category the new data will fall under. Like another example we can take for the disease. Somebody having a disease. So there is a two possibilities. You are going for a examination, you are going for a checkup, then there would be two possibility. Either you have a disease or you don't have a disease. So what we need to do, we need to train our model with certain training data to understand our input variables related to that particular classes. There is our input variable can be related to a class yes or a class no. Once our classifier is trained, then it will predict the values. Okay, so some terminologies I'm using here, have you heard about this? Like sometimes I call it classifier. Okay, classifier is basically what? It is a model. You can say it is an algorithm that used to map the input data to the specific category. Or classification model. I can also call it classification model. Okay, the model which predicts conclusion to the input data given for the training. Okay, and I can also call it, there is two types of this classification or logistic regression. Two types of, one is the binary classification. In the binary classification, we divide the outcome into two classes only, either 0 or 1, or you can say false or true. And second one is multi-class classification. In the multi-class classification, we predict multiple classes, not only the two classes, more than two classes. Two classes. Okay. And other things you already know: train the classifier, predict the target, evaluate your model, initialize the values. These terms I'll just use. Okay. Somebody asking a question, logical regression is a type of classification. Then why name like regression? Actually, it's a type of regression, you can say. Or classification, both are the same thing. Like task, work we are doing, that is the classification here. Basically, logistic regression is we are finding a best fitting relationship between dependent and independent variable, and here the output we are not getting, like in the regression we are making a line, we are creating a line. Here what we are doing, our graph would be like this, and here prediction we are doing either two classes, like certain classes. If I talk about the binary, then it is two classes only. Basically, logistic regression is specially meant for the classification. Okay. Like some use cases you can understand with this classification or logistic regression. Some use cases we are using, like we can find, we can do the word classification. We can do the weather prediction. We can do the voting applications. And we can find the risk factor for disease. Okay? Or either spam or not. Okay? These type of things we can do. Okay? Now we will come back to our article and we will see here what is the logistic regression. Logistic regression in the machine learning and its example, it is a statistical model for analyzing a data set in which there are one and more independent variable that determines an outcome. This is technical definition. Like what we are doing here, we are predicting either 0, 1, yes, no. And multinomial means we are having more than two categories, 3 or more categories, like such as married, single, divorced, and widow. These are the 4 categories for a person. Okay, so we will do one use case of iris dataset. We will pick the iris dataset and then we will do the classification over this. Like what is the iris dataset? Iris dataset is it is for flower classification and to identify the different species of the iris flowers. And there are the given features are the 4 features. What are the 4 features provided to you? The sepal length, petal length, sepal width, and petal width. 4 parameters we are having, 4 features we are having, and we are going to predict one of the category. Okay, and some techniques for the feature enhancement, I'll tell you like what is the label encoder and what is the one hot encoding. Meanwhile, we will discuss these things also. Okay. So now come to this, I'll start implementation using Google Colab. Okay, we will do the implementation. Implementation of logistic regression. Okay. And here we are going to use the data set that is the iris data set. So first we need to include all the data science libraries which we are going to use during this implementation. Okay. So here you can see I need to import pandas, matplotlib, numpy and sklearn. Okay. So let me write here And we will see certain things here. Like whatever we have done last time, we will see some more things. Import numpy snp. Although for every model there are the sequence of steps is same, because in the machine learning same thing we are doing. First we will see the data, and then we will analyze the data, we divide the data, and then we train the model, and then we will do the prediction. So all the steps are same, but we are going to do some different task also here. Okay, and then import pandas. Import sklearn. And then from sklearn dot linear model, here what I'll import, here I'll import logistic regression. Okay, logistic regression. These are the libraries I need to import. Now I'll import the data set. Okay, so I'm picking the data set from sklearn. What happened? Cannot import logistic regression. Yeah, this is wrong one I have picked. Here R is capital and L should be capital. Logistic regression. Yeah, this one is correct. Now I'm importing the data set. Import data set. Okay, and then here I'm writing from sklearn dot data set import load underscore iris. There are the lots of data sets. Okay, and then I'm putting iris equals to load underscore iris. Okay, so now my data inside the iris variable, I'll print iris. And this is the data set you can view. Actually, here we have data array, and inside the data array we have 4 features. These features are sepal length, petal length, sepal width, and petal width. If I'll scroll down, then you can see there is one more value is target, and target having values 0, 1, 2. So 3 categories. You can see in the output there is categorical value, 3 categories only. It's not a numerical value, it's not a continuous variable, it is a categorical value. We are going to predict a discrete value. That's the difference with the linear regression and in logistic regression. Okay? Now what we will see, I'll check this data set and I'll see all the keys, iris.keys. And you can see the keys, data, target names, description, feature names, and file names. So what I want to see the target names. What are the target names here? Okay, so I'll check the target names, print iris dot target names. And you can see target names are Setosa, Versicolor, and Versinica. These three type of flowers we have. Okay, and corresponding values we have 0, 1, 2. Similarly, I just want to check out the feature names. So I can print feature names. Okay, iris dot feature names. And you can see the feature names are sepal length, sepal width, petal length, and petal width. As I told you, we have 4 features, and on the basis of these 4 features, we are going to predict a category, like what category of particular record belonging to the particular flower. Okay, same thing we need to do. We need to convert iris.data into a data frame, and then we are going to do some other task. So first thing, I'll convert my data into data frame. df equals to pd dot data frame, and then I'm writing here iris dot data. Iris dot data, and then here I'll print df dot head. You guys please do along with me so that you will get the things properly. Okay. Now what I will do, I'll just want to put it here, the name of the features. You know how we can do? We can do simply by using this df dot columns equals iris dot feature names. Okay, and then I'll print df dot head, and you can see the output. Here we have put it the feature names. Okay, this is our data information, like this is our information about the data, what the column name, sepal length, sepal width, and petal length and petal width. Now if we want to know more about this, okay, then we can use this function like this, df.info. This will give you the information about the data, like what the df. What is the df? df is a class of data frame. It having 150 entries, 150 records, columns total, it having 4 columns. And you can see here the first column is sepal length, second column is sepal width, and petal length and petal width. Okay. Now what we will do next? We will divide our data into x and y, or you can say dependent variable and independent variable. Okay. So same thing I'll do here, x equals to iris.data. Okay. And this is my independent variable. Similarly, I'll write here y equals to iris dot target. This is my dependent variable. And then I'll print shape of x and shape of y. So x dot shape, and then I'll print y dot shape. Okay, now I'll run it. And you can see here x dot shape, x having 150 rows and 4 columns, and y having only the 150 rows, means only the single column. That's the thing we want. Now I'll tell you one concept of data, like whenever you are getting some data, what you need to do, you need to check out the data. Like yesterday I have told you, like some data, some column having a range of data in 5 digits, and one column having starting from the 5 digits, it can be 5, 6, 7, 8 digits, or one column having data only in 2 digits. So what will happen, the column which having more digits data will have more weightage. So what we will do, we will normalize our data. We will do the scaling of our data. We will standardize our data. So here I'll explain you the concept of standardization, how we can do the standard scaling of data. Here you can see data is scaled already because I have taken the data simply from the sklearn, and in the sklearn data is already scaled. But I'll explain the concept of standard scaling, how we can do this standard scaling if our data is not scaled. Like our data is one column having 6 digits values and another column having 1 digits value or in the points. So what we will do, we will do the standard scaling. I'll tell you here the concept of standard scaling. You can say scaling of data. Okay. So we will see this one important concept, how we can do the standard scaling. In the sklearn, like simply you can do some mathematical process, like what you can do, your column value is x and you can subtract some value, like min value I just want to subtract and I just want to divide by max, something max minus min. Okay, so what will happen with every value in the column, we will do the same task, then nothing will happen. What we'll do, what we will get at the end, we will get at the end a value in a range of 0 to 1. So kind of things for the scaling we will do, like in the maths, in our school days, we used to do these type of things. We scale our data. So this type of formulas we apply. So here from the sklearn, I'll use standard scaler. Standard scaler in sklearn, I can tell you, this is one of the way for doing pre-processing. So sklearn, there is a package called the pre-processing, and from the pre-processing package we are picking standard scaler. Means standardize features by removing the mean and scaling to the unit variance. What the formula they are applying, they are doing x's value, okay, and they are subtracting from every x minus u is here the mean, and divide by s is standard deviation. So with every value they are doing this operation, x minus u divide by s. We don't need to write manual formula, it is automatically applied when we use this standard scaler function. But I am telling you what actually standard scaler is doing. It's doing certain operation in the form of this formula. Centering and scaling happens independently on each feature by computing the relevant statistics on the sample in the training set. Okay, so for every sample we will do this, for every column we will do this, for that column we will calculate mean and we will calculate the standard deviation, and then for every value it will do. So for the training data set, complete training data set, it will calculate mean and standard deviation. So how we can apply this formula, like we have sklearn, from sklearn.preprocessing import standard scaler. Okay, Or then what we can do, we have some data like this 0 0 0 0 1 1 1 1. Then we will import this standard scalar. We will call this function a standard scalar into the scalar, and then scalar dot fit this data. Okay, or there is two more functions. One is the transform and another is fit underscore transform. So what happens, this fit will do, it will compute the mean and standard deviation, and transform will apply this mean and standard deviation to the data. Like using this fit function, we are calculating mean and standard deviation, and using transform function, performing standardization by centering and scaling. Two functions you are getting, one is the fit and another one is the transform. And one more function, fit underscore transform. We can use this function also. This function you do the both things together, like fit to the data and then transform it. It will calculate the mean and standard deviation as well as it will transform data, do the standard scaling. And inverse transform, it will scale back the data to the original representation. Okay? So generally what we will do, for the training data, we will apply fit underscore transform. Okay, and for the test data, we don't need to do this fit underscore transform, because fit underscore transform is already calculated the mean and standard deviation. So we will apply transform only for the test data. Okay, this is the thing we are going to do. To this function, standard scalar, we call a standard scalar. From the standard scalar, we are going to use this fit underscore transform or this transform function. Generally, for the training data, we use fit underscore transform, and for the testing data, we use the transform. Okay, now I'll come back to our article, come back to our implementation part. Okay, and here I'll import this standard scalar. Like in this example, I don't need this standard scalar, but I'm just telling you, like sometime you will get the data like this. Then you need to do this. sklearn.preprocessing import standard scalar. Okay, and then I'm taking a variable sc equals to standard scalar. Standard scalar function. Now I'll apply this to our train data and test data. So x underscore train, like first I need to divide the data. Okay, one more task I need to do here. Okay, so first I'll split the data. Splitting train and test data. X underscore train, X underscore test, Y underscore train, and Y underscore test equals to what I need to use? I need to use the train test split function. So sklearn dot model underscore selection dot train underscore test underscore split. and here I'll write x, y, and then I need to provide the test size x comma y, and test size I'm taking here test underscore size like 0.25, and then random underscore state equals to 1. Okay, x, y, test underscore size and random state equals to 1. This thing I am doing here. Now I can run this block. Okay, so we have divided our data into two parts, training and testing. Okay, now we will apply the scaling. From sklearn preprocessing, import a standard scaler and then sc standard scaler, and now I'll write here x underscore train, okay, equals to sc dot fit underscore transform. Okay, and here I need to write x underscore train. We don't need to apply the to the y train and y test, because standard scaling is only for the features, it's not for the output. We don't need the scaling for the output. Output is basically classes. Okay, so we are doing this task only with the x, only with the features, scaling of the features. X is basically features. X underscore test. Now I can run this part and this will do the standard scaling. Like here I can view the output like x underscore test dot head top 5 records. Sorry, caps. What happened? Okay, it's an umpire. So you can see now the output of x underscore test is in a fraction values. For this case we don't need this one, but I have done just for understanding purpose. Okay, so now we have divided the data and we have done the scaling part also. And sometime what happened, we have data in the form of string. So that time also we need to convert that data into numerical values. That also we will see one example. First complete it. Now the logistic regression. Model equals logistic regression. Okay. And then here model dot fit x underscore train, okay, and y underscore train. Okay, this is our model is trained. Okay, now we will do the prediction over the data, and here one more measure of accuracy we will see confusion matrix. Okay, so first we will do the prediction of our data. There are lots of things in the machine learning. Okay, y underscore predict equals to model dot predict x underscore test. Okay, and then I can print y underscore predict, and you can see the sum output is something like this, 0 1 1 0, like this. Okay, now we can see the performance measure. Like, we will see how much records are correct or how much are not correct, accuracy. Okay, so I'll calculate confusion matrix. I'll explain you what is the confusion matrix. First, I'll calculate here. From sklearn dot matrices import confusion matrix. Okay, and then confusion matrix, you can calculate confusion matrix what we need to put here, y underscore test with y underscore predict. Okay, and then we will print this confusion matrix. And here you can see the output. Actually, these diagonal are the correct values. Now I'll explain first confusion matrix. Don't confuse, okay? Okay, so now we will understand what is the confusion matrix. Here, what will happen, like we have certain values, okay? In a categorical classes, in a categorical machine learning, what we will do, we have certain actual values. Like there is only two labels. One is the label 0 and another is 1. Okay, in a output, two classes, either 0 or 1. Okay, so actual classes, we are writing here actual class. Okay, and we are writing predicted class. Actual class is 0 and 1, like for certain records. Okay, and predicted classes, there would be two classes, 0 and 1. Like if we are taking a record and for that record, actual output should be 0. And our model is also giving the 0. Okay, for a particular record, if output is 0, actual output is 0, okay, class is 0, and our model is also predicting class 0, it means our model is predicting true. Okay, and it's a predicting, like this thing we are taking negative and this is a positive. Okay, and this is negative, 0 we are representing with the negative and 1 we are presenting with the positive. So this is predicting the true, and with the true it's predicting negative value, so we call it negative. true negative. Similarly, if our actual value is 0, but our model is in place of 0, it's predicting 1, means it's predicting false. And what's it's predicting false? False, it's predicting positive value. Okay. Similarly, our actual value is 1. Prediction should be 1, but our model is predicting 0. Means our model is predicting false. And what it is predicting? It's predicting negative value. So this is false negative. Actual value should be 1 and our model is predicting 1. This means our model is predicting true. And what it is predicting? True positive. So you can say here, like values, we have diagonal values are the correct values. Either it is a true, negative or a positive. But diagonal values are correct prediction. Okay? So we can say diagonal values are correct prediction. So if we want to calculate the accuracy, then what we can say? Diagonal values. So we represent this true negative Tn and true positive Tp. False positive is Fp and false negative Fn. So what we can write? Accuracy is true negative plus true positive divided by all 4. Means true negative plus true positive plus false negative plus false positive. All 4. This is actually our accuracy. Like you can say we have total 150 records. Okay. Out of 150, our model is predicting correct 0 are the 50. And correct 1 are the 80. What are the remaining things? Remaining is 50 plus 80. How much? It's 130. So 20 is false. So out of 20, 5 is falling under false positive and 15 is falling under false negative. So you can say accuracy of this model is 30 plus 80 divided by 30 plus 80 plus 5 plus 15. So you can say it's a 110 divided by 150. Okay. It's a 30 or 50? It's a 50. So it's a 50. So 130 divided by 150. This is the accuracy of the model. Getting? What is the confusion matrix? Little bit confusing. But you should understand this. What we are having here, we have 2 classes. And if we having multiple classes, then also we can write the confusion matrix. But just understand with the help of only the 2 classes. Okay. 1 is you can 0 represent 0 and 1. 0 we can call it negative and 1 we call it positive. These are the actual values. These are the actual values. And these are the predicted values. So actual value, like how much 0 our model is predicting 0. Like we have total, suppose how much 0 our model is predicting wrong, that is the 5. Like total 0 class value, we have 55 classes in the 0. And total 1 classes is 80 plus 15, 95. 95 records, output should be 1, and for 55 records, output should be 0. But what we are getting, for the out of 55, we are getting only the 50 correct. 5 we are correct, model is classifying wrong. And out of 95, we are getting 15 wrong and 80 correct. Yes, confusion matrix values can be different for everyone. Because it depends on your machine, it depends on your thing, how your model is picking the data. But the accuracy is almost same. Okay, now come to this, and you can see here the confusion matrix for Y test and Y predict. Here we have 3 classes. As I already told you, we have 3 classes. So correct predictions are the diagonal predictions and wrong predictions are remaining. So this is basically confusion matrix. You can calculate the accuracy with the help of confusion matrix also in the case of categorical data. Okay guys, can you give me a quick confirmation? Are you getting the things? Okay, and one more thing we can calculate the accuracy with the help of accuracy score. Okay, so there is another function we are having inside the sklearn. sklearn.matrices, okay, and then import accuracy score. Okay, and here you can print, there are the lots of things inside the sklearn. Okay, accuracy score of y underscore test comma y underscore predict. And it's around 97%. Okay, so like this we can do the prediction for the categorical data also. Like we have created model, simple thing, we can do the prediction also using the same function that we have done in the last. And same plotting also you can do. The remaining things are the same. Now I'll pick 2-3 concepts that we need generally in the feature engineering. Like while you are viewing the feature, you need to convert the features into the certain values. So now I'll pick one concept is one hot encoding, and another concept is called label encoder. Okay, so 2 things we are going to study, what is the one hot encoding and what is the label encoding. We are going to do with the help of sklearn. Okay, so first of all we will see why we need one hot encoding or one label encoding. Basically what happens sometimes, like in our data we have some strings, we have some text, and you know in the machine learning, machine doesn't understand the numbers, it doesn't understand the text, it basically understands only the numbers. So what we need to do, we need to convert each text category to the numbers. Like what we are having, Okay. Sometimes in our data set, we are having certain like name of the cities, name of the countries, India, US, okay, in a column, UK, something like this. And another column having some numerical value 10, 20, 30. These are the two features. On the basis of these two features, feature 1 and feature 2, I just want to get some third feature, some output, some target. So what I need to do, I need to convert these string values into numbers, because my machine don't understand string values. Okay. So label encoding and one-hot encoding comes into the picture. Okay. So like in your data can be combination of, you can say, data can be combination of numerical data as well as categorical. So that categorical data you need to convert into the numerical form. Convert categorical to numerical. This is main motto. Okay. So first we will understand label encoding. What is the label encoding? This is popular encoding technique for handling categorical variables. What happens here, each label will be assigned a unique value. Okay. So here the country's name will be assigned a unique value, unique numerical value. Like here, India can be assigned 0, US can be assigned 1, UK can assign 2, and if there would be some more countries' name, they can assign 3, 4 like this. And country's name can be repeating. So again, whenever the India appears, it will give the same number, that is the 0. And for US, it will give the same number, that is the 1. These things we will do with the help of label encoder. And label encoder can use alphabetical order. Like on the basis of alphabetical, like on the basis of alphabets, it will assign some numerical values. But what happens sometime, our data will create some relation with these country codes. But actually, the country name don't have any relation with all these things. Like numbers will create some relation. So what we will do for, like, what happens, it will do the comparison like this: India is less than US, less than UK, something like this. It will create some relations in between countries. So model will capture these relationships. So what we will do generally, we will convert these, if we are doing for the categorical data, like for the target data, for the output data, then we will convert that output data into one-hot encoding. Like if I am doing for the feature, then it's okay. But if I'm doing for the target, like in the target also, there can be three categories. Like for, if I'll take the example of flowers, there can be three categories. In place of 0, 1, 2, there can be three categories stored in the output. So I need to convert those categories into one hot encoding in place of label encoding. Label encoding generally I do for the features. One hot encoding I'll do for the output variables. What is the one hot encoding? It's also treating the categorical variables. And it creates extra features. Like you can say here, in this column, it will check unique number, like total number of classes. Suppose there is 3 countries name. One is the India, US, UK. It's repeating 3 countries name only, 3 classes only. Then classes value is 0, 1, 2. Only 3 values. Then what we will do in the one hot encoding, we will create 3 output like 0, 1, 2. And if a class belongs to 0, then what we will do in the one hot encoding, it is belonging to 0, then we will make this one 1, others 0. And if class is belonging to 2, then we will do this 0, and in corresponding to 2, 1. Similarly, if class belonging to 0, then again we will do 1, 0, 0. It creates additional features based on the number of unique values in the categorical feature. It's basically creating some dummy variables. One hot encoding is creating dummy variables. How much variables it can create? Number, as many unique variables. Okay? So basically, these two techniques we are doing when we treating with the data. When we working with the data, we need to convert that data into certain forms. Okay? Got it? What is the label encoding? How we can do label encoding and one hot encoding in the practical part? We will use library sklearn, and from the sklearn library we have certain functions there. Okay, so I'll tell you how we will do this part practically. Okay, import label encoder. Okay, and here we will write from sklearn. You can see example in the sklearn only. Sklearn, I don't need to write again and again. Sklearn, what label encoder. Okay, this is pre-processing library. In the documentation itself, you will get the things. Pre-processing label encoder. Target labels with the values between 0 and number of classes. So what we will do here, you can see. From the sklearn, import preprocessing, and you can write here also from sklearn.preprocessing import label encoder. Then label encoder we will put inside a variable, okay? And then we will do the label encoder fit. Number of classes you can see with the help of le.classes underscore. Okay, and here also we have same functions fit and transform. Both we will use fit and then transform. Like you can see here the example also. label encoder we have taken, and the data we are having Paris, Tokyo and Amsterdam. And then with the help of label encoder, we are converting these into certain numerical values. 221. Like we can do this same example. We will pick this value from sklearn dot preprocessing import what I need to label encoder. Okay, and then here LE equals to label encoder. Okay, now I'll use this example. LE.fit Paris, Tokyo and Amsterdam. Okay, and then I need to write one more thing here. Like I just want to check the list of classes, then I can write like this. These are the list of classes, means unique classes. You can get it with the help of this le.classes underscore. Okay, and similarly you need to convert now. You have done only the fit, now you need to do transform. And it will give you certain values like 2 to 1. Okay, and you just want to get the inverse transform, then you can get back the names. Like I'm writing here list of le.inverse underscore transform and then this values. Then you will get the again Tokyo and Paris. So this is the label encoder. In place of this array, you can pass your column. Okay. Same thing with the one hot encoding. There is also one function for the one hot encoding. From the pre-processing, we need to import one hot encoder. We can see the example for one hot encoder also here. Okay. Now you know the concept. Then you can understand from here. I just want to see the example. Like we need to import the one hot encoder from sklearn.preprocessing, import one hot encoder. And then this one hot encoder we will store inside a variable enc. And if we have data like this male, female, then we can convert this into, like output should be in the two classes. As much categories you have, you will get the final classes. And one only present where our classes, this is not a good example. Let me write. No, this is not the, you didn't get the completely. Actually what happens here, if I'll take an array like this, male and female, then it will give you for the female in output 2 columns. One is the for in a female, in the output you are getting 2 columns. I'll write here. One hot encode, one more time I'll tell you. Okay. I have 2 classes, male and female, in output. Okay. So in my output is something like this. male, then male, female, male, female, and male. I just want to convert this into one hot encode. Then what would be the output? Obviously, corresponding this, we will draw the lines. Okay? And then what happens here, output would be in the two classes. Like how many unique classes here? 2. Unique values is 2. So what we will do here, we will write here. First one is male and another one is female. So for this, in place of male, we will get 1. Okay, in place of male, we will get 1. And in place of female, we will get 0. For this, male, we will get 1, here 0. For female, we will get here 0, here 1. For male, 1 and 0. For female, 0 and 1. And for male, 1 and 0. Okay, so this is called the one hot encoding. And using the function, you can try it. Okay, I think you got the concept of one hot encoding and label encoding. Now you can do the different task. Okay guys, can you give me a quick confirmation? Are you getting the things or not? Like what I have covered till now, what is the classification and different applications of classification, how we can implement the classification. We have solved one example of iris dataset. We have seen the confusion matrix. We have seen the standard scaling. We have seen the one hot encoding. And I hope you are getting all these things. Okay, so sklearn datasets. Let me give you one example. No, this is something wrong. sklearn datasets, and inside this datasets we have certain datasets like Boston yesterday we have used, that is only for the regression, and iris dataset we have used today, that is for classification. What you need to do, you need to try these two, diabetes and digits. Diabetes is for regression and digits is for classification. So you will do the good exercise, and you can also try the wine dataset also. Just try any of them, like one for the regression and one for the classification. Okay, so you will get the clear picture how we can see the data and different things. And other examples also you can pick from the internet and you can solve, like now you know lots of things. Scaling also you know one hot encoding also, so you can solve the different examples now. Now you are eligible to do some practice. And there are lots of things also available, so you can search out something by yourself also. Okay, so till now clear the things, and I think enough for today. Okay guys, do some practice, and thank you so much. Good night, see you tomorrow.